Okay, so once again, good evening from my side to all of you. And today, I last week when we met, I made a promise to you guys that when we meet next time, we are going to we are going to be doing some projects like some real world projects. We are going to be putting all the basic things that we learned last time. So, a quick recap of what we learned what we've been doing so far. We started from the basics of R, where we talk about what R is, what R can be used for, and then we also talk about the fact that um, we talk about variables, how we can declare variables in R, the type of variables that we have. We also talk about what was we talk about data types and how we can create data types, how we can manipulate data types. Then we talk about loops and then conditionals the last time, and then functions. So that is what we looked at the last time, and we've been able to go through all of these things. And I told you guys last week when we met that when we meet this week, the last time we met, when we meet again, I would want us to put everything that we've learned so far into practice. So um here we are. So let's get started. I hope all of you are excited and you are ready for this class. So I would like to share this notebook with you guys as usual so that you can work with it. You can copy this and then save it somewhere or use it. Um, Another thing is that the um, project file that I'm using. Uh, oh boy. Okay. Something is happening. Share this. Network. Okay, so yeah, so let me give access to everyone who owns this. So copy this and then done. Okay. Um, yeah, I hope I've not lost you guys. So I was saying that uh, here is the link to the notebook that I'm using. The file that we'll be using, if you are interested, I would you can hit me up in the group chat. Okay, the file that I'm using for I honestly generated it's just a synthetic data though. I didn't really it's not like a real file. It's something that I generated using Python code. So if you are interested in generating that, I can you can let me know. I can share that notebook that I used to generate the synthetic file for you. Um, because I wanted us to do something that would be um that would resemble real world applications. Okay, I searched for some files on Cargo and I didn't really get any interesting file there. So I just took some for the purpose of our class. So for the purpose of our class, I just took created some synthetic data. If you are interested in the group, you can just or come to my DM. I think you guys can find me on the WhatsApp chat, and then just come to my DM. You can let me know. I can send you the notebook there, and then you can also just generate your own synthetic data from that using that. So let's get started. Let's get back to this. Sorry. So the first thing that you would want to do whenever you are working in R is to be able to install packages. So here I'm just installing this GG, yeah, so ggali package. You can also install these packages, but tidyverse, deepir, and then readr are mostly inbuilt packages. So you just you just read them directly, and then you don't really have to worry much. But if you want to install any package in R, you use this method. So install dot packages and then the name of the package. So you put the name of the package in this quotation mark, and then you are able to install that package. So this is how you install a package in R. If you are working if you are working in the what's the name, the R Studio. If you are working in R Studio, to the same thing, you just type this and then it's going to install the package for you. Like I said from the very day we started, I am using this because I want to be able to share the notebook with you guys always whenever we are working. Because I saw that if I'm working locally, sometimes it's very difficult sharing the this thing with you guys. But if I'm working, or if I can also use proxy though, but I think it's just a preference though, so maybe you guys will understand, would bear with me. Yeah, just bear with me though. So I've this is how you install a package. This is the same way, this is the same thing you can do whether you are working in R Studio, or you are working with the cloud version, that is the Proxy Studio, yeah, in R on online. Then to load packages, you use library and then the name of the library. So the name of the package you want to load. You know, if you are coming from Python, you would see something like import, then the name of the package. Here, you to read libraries, you just type library and then the name of the library. You put that in square brackets. Yeah. So, so let's talk about tidyverse. Tidyverse is just like a set. This contains other libraries in it. So, it's a data science library that is mostly used for anything that has to do with data science, anything that has to do with loading data, reading data, data manipulations, um, and anything about data science. We use the tidyverse for it. And then the DPyR, we pronounce it DPyR, but DPLYR. This is mostly used for data wrangling. So you will be able to read the data, and then this contains some functions like the mutate, like filter, recode. So if you want to be able to wrangle your data, like you want to be able to um, um, filter some columns out, you want to be able to get some column values out, you want to be able to group your data, you mostly use this library to be able to do that. So we mostly use this one for mostly used for mostly used oh used for data wrangling. How do we spell wrangling? Yeah, yeah. So this is mostly what we use it for. Then read R is mostly used for reading data. So read CSV, read CSV, read table, read Excel, read yes. So mostly we use this to be able to read data into our environment. Then Gigi Gali. Ggali is just an extension of ggplot, which would also tidyverse mostly comes with ggplot. So if you have loaded tidyverse, there is no worry about you loading ggplot again because you have tidyverse already loaded. So G, ggali is just an extension of ggplots. This is mostly used for plotting correlation. So mostly use this for plotting correlation charts. So you mostly use it to plot correlation charts. So this is mostly the libraries that we're going to be using. And then you guys It is mostly, in in those of you come from the Python background, you'll be able to understand that. For instance, if you read, let's say CS, let's say pandas, you said, okay, read import pandas as PD. Mostly when you are going to use the pandas, you mostly refer to pd dot that do something, dz dot do something. In tidyverse, we don't mostly do that. Sorry, in R, we don't mostly do that. All you need to do is just know the functions um, that comes with the libraries, and then you just call those functions straightforward, and then they'll work. What I'm saying is this. So read R comes with a function called read underscore CSV. So this read underscore CSV, you don't really need, in Python, you do pd dot read underscore CSV, but this read underscore CSV comes, oh yeah, it comes with read R. So you don't really bring this first before you just have to know the function that it comes with it, and then you can just go straight forward and then read, and then you go. So this is installed, you run this cell, it's going to install this for you. This our libraries have also been loaded and then just like in Python, you read your you give the name of your data of the data frame you want. So here we are using df for it, and then we've met this before, which we know is the assignment um, operate operate operator. Yeah, so operator, and then we have this function, and then we have the path to our data set. So here I have loaded this data set. Like I said, this is just a synthetic data that I've used. So 500 synthetic bio machine learning data set. I created this using a Python code. So you can, like I said, you can just hit me up and I'll send this to you. So this is for this. And then don't worry much about this. Is as far as this has run, this is mostly just telling us that, giving us some information. It's not like this is not going to run or there is a problem with the code, but this is telling us that if you want, we should specify show call types to false to be able to quiet this down. Because if you run this, it's going to give you these things. It's going to show you the columns that you have and probably the column types that you have. The reason is that we have 8 columns and then age, gender, and then so this is just giving us some information. So that is what is happening here. Don't worry about this. This is not an error message to worry about. Then, sorry. The next thing is for us to do data exploration. So with data exploration, we need to be able to understand the data that we have, what is inside that data. So we want to be able to see the first 6 rows. In Panda, in R, when you do head and then you put your data frame into it, this is going to give you the first 6 rows. So this 1, 2, 3, 4, 5, and then what, 6. So this gives us the first 6 rows. So we want to get the first 6 rows in this data set. Now, when you do this, I want you guys to understand something. So first, we have what we call a table. So here, R reports, anytime you are working in data frame, R reports them as table. So I don't know, this is just something that is specific to R, and it gives you the dimension of the table that you have. So we are having 6 rows and then what, 8 columns, and then it gives you the table, the column names. So we have column names here, and then this is the most interesting aspect about R. In Python, it won't tell you unless you explicitly ask it to give you the column types, that is the data type of the columns. But in R, it is automatically going to tell you, okay, so this is CHR stand for character, this is also a character, this is also a character, this is also a character. So you can say all of them are character variables. This gives us an information. So this makes us to understand the type of data that we are working with. So if we have this, all of them are characters. So you can say that in general sense, age shouldn't be a character, but I guess that we have some value here, which is the reason why this is being a character. Now, gender is a character good. Educational level should be characters. Region should be characters. And then here, lab results score. Score shouldn't be characters. It should be numbers. So we have these that you can work with. So these are just some interesting things that we need to know. We need to note down. So that is, we are exploring the data. I want to know more about our data. So that is the first that we do. So we get the first six rows, and that is sorry, that is giving us this. Then the next thing is that we want to get some samples. So to be able for us to be able to understand our data, so to be able to do that, we use this is slice samples is still coming from this library here. Um, Mostly it is it is mostly if you have tidyverse loaded, slice samples will come with it. If you have DeepIR slice samples is going to come with it. So we just want to take 10 samples from this. Sometimes you are working with a data set and you want to get a glimpse of the data set. Maybe you want to know what is fully inside our data set. So yes, use samples to be able to do that. And I'm going to be referring to Python because I know most of you come from the Python background. So um, you might have some ideas from there. So in Python you do samples. So um, sample so pd dot sample and then you get your the sample or the sorry the df dot sample and then you get your sample values there, but here we use this slice sample. I want you guys to take note of this symbol. This is called the pipe symbol. So this percentage and then the greater than and then the percentage is called a pipe symbol. Pipe symbol in the sense that we want whatever we have here, we want to put that back into our data frame. So we want to take a slice, 10 of these 10 of these samples of these data sets, of these data frames. So that is what slice stands for. Yeah, this is what slice sample is. And then this is what this. So anytime you see this, know that we are taking this and then we are whatever we are doing here, we want to perform that thing on this. So that is what this pipe symbol stands for. So if you take 10 samples of our data set, you would see that it gives us some more idea about the fact that, okay, this column here has some dashes in it. That is the age column. So that is probably the reason why it's what a character. And then the lab result has some um, dashes and then some values called 9. So instead of writing the values as 9, they spelled 9. And we have some NA values. So in pandas, NA capital N capital A stands for what? For not a number or not a value and a value. So you see NA. Please take note because small n small a is not the same as in Python, NA, so capital NAN. So you see something like this. But in pandas, it is NA, which telling you that it is not what a number. So there is no value that is inside there. So this is giving us some ideas here too. We have this. Then we have some unknown values here. Even if you look, okay, so here too we have northeast, we have southeast. Is that some of them are spelled with capital letters. Even this northeast is different from this northeast. So this is giving us some idea about our data because this is all about data exploration. This is what you do. And this is mostly the tedious part when it comes to data science because you need to be able to explore your data to know what is inside that data before you start doing anything that you want to do to that data. So now let's start looking at some things. First of all, let's look at our column names. Okay, so what are our column names? So if you use call names here, this is going to tell you that, okay, we have age, we have gender. I know we can see them here though, but assuming that you have um, you have a data set that has about 80 column names. Some data set can come and we have about uh, there was one data set I think I worked with before that was having more than 800 columns, and then we have to do some um, um, data manipulations. Sorry, we have to do um, oh, reduction. What's the name? Something reduction. I've forgotten that. But we have to reduce. We have to use PCA and then TSNet to be able to reduce the number of columns that we have. Oh, I've forgotten the it's called something reduction. Yeah. Um, I don't know if you guys know it. Maybe you can put it in the chat. Yeah, but this is how we get the column names. So you mostly use these core names, and then so you want to access the column names of this DF, and then this gives you the column names. Then the next thing is the dimension. So what is the dimension of a data set? So in Python you use shape, right? But in R, sorry, that is in pandas you use shape, but in R you use dimension. So you use dim. So dim df. So the dimension of what of our data frame, and the first value here is telling us what the row. I think I've always told you guys this. Okay, back to this. Let me stop sharing this and stop and share my all my screen. I think. Wow. Okay, we have only Vivian here. Let me share all my screen. Vivian, I hope you are following. By the way, share. Hide this. Vivian, let me know if you can see my screen. I think you are the only one that is left with me. Okay. So I presume, yeah, everyone is here. So let's go. Let's go. So I think I told you guys this last time that if you have so these are DF. If you have a data frame, the first value that is C, and then the second value. Um, okay, yes, you can see. Thank you so much for that feedback. So three here. So the first value here stands for the row when we're treating this, and then the second value here stands for what? The column. So if you get back to this, you would see that if we want to print the dimension of we want to print the dimension of our data, then the first value here stands for the rows. So there are 500 rows. Then this value here stands for what? The columns. So there are 8 columns in our data set. That is what this means. Then the next that you want to be able to do whenever you are dealing with a data set is you want to be able to find the unique values of the columns. What are some of the unique values from the columns, especially in the categorical columns? So you want to be able to know the unique values that are inside the categorical columns. So we learned about functions. So this is just like a helper function that I've created that prints out the unique values of a given column. So you have this is a function name, and then when we're treating function, I told you guys that you define the function using the function keyword, and then uh, you give it an argument. So the argument here is call name. So the call name is going to be the column names, and I want to print the unique value of that column. So these are helper function. We run this. I brought this because I want to you guys to know that the things that we've learned so far are the same things that we are doing here. So that is it. But you can also use this unique function which automatically comes with tidyverse or diffbyr, so it automatically comes with it. So if you want to find the unique values of the each column, now I want you guys to take note of this because don't always go about and then be doing unique, because sometimes your screen is going to just, especially when you have like about 10,000 data points. You have about 8,000 data points and you want to do this unique on maybe a column that has about high cardinality, or yeah. So if it has high cardinality, you would just your the values are just going to be displaying on your screen just like that. So take note of that. So this is just something that some caveat that I want you guys to take note of. So mostly you check the unique values for columns that the values that are in it are not mostly having high cardinality. Like they are not they are just less than 10 or maybe 20 or so. So that is something that this is just a caveat that I want to put forth. So this is a function that we define, and then we will just want to test this function here whether that also works. So yes, that whether we use this unique and then the column name, or we use the function that we define, and then it's still going to do the same thing for us. So that is it. Now, something that I think I need to let you guys understand before we go is how we assess column names. So, how we can access a column name. Now, if you do, let's see, we do df, and then I made mention, I told you guys about this. So let's just say we are taking gender. Um, when you do this, this is going to print all the values in our gender column. Okay, so this is how you access a particular column in a data set. Now you can also access this column using these two square brackets. So you use these two square brackets and then we get the gender from it. So when you run this, it's going to give us the same thing. Um, so I think when we were doing, if you guys remember, you would see that we did something like this, where I showed you guys. So doing this, they're going to give us the same thing as doing that. So this is something that I explained to you guys already when we were doing the data structures. That you can in a data frame you can use this to be able to access a particular column, or you can also use the dollar sign, the data frame name, and then the dollar sign, and that will also give you the column that you want. Now we can also access a let's say you want to access some specific columns, some specific rows, or you want to take some specific rows from another specific column. So if you guys also remember, we also did something like this where I told you guys that let's say you want row 3, you want to slice row 3, and then and everything from maybe row 5, yeah. So we do this, and this is going to give us row 3, and then the value in what in the third column, sorry, in the fifth column. So this is something that we can also do. So if you get back to our data set here, this is row 1, row 2, row 3, and this column 1, column 2, column 3, column 4, column 5. So row 1, row 2, row 3, and then the column value. So 1, 2, 3, 4. Uh, oh, wait. Where were we? Yeah. So row 3, column 5, the value there is what is this? So if you get back to this place, we have row 3, so 1, 2, 3, row 3, and then column 1, 2, 3, 4, 5. So this is the value that we are picking. So this is how you get a slice from the data. Or we can also do something like this, which I also stated it when we were doing the data structures, that if you have df, let's say you want to select some set of rows, then set of columns. So let's say you want to select row 3 to, let's say, 5, and then we want to also select column 2 to, let's say, column 7. When we run this, let's see what we get. Good. So this is giving us, this is going to go to row 3. So from row 3 to row 5. So row 3, row 4, row 5. And then it is picking column 2, column 3, column 4, column 5, column 6, and then column what 7. So these is something that we also talked about last time. So, because if you guys remember when we were treating data structures, I made mention of this. If you guys could remember, I made mention of the fact that if you have these are DF, so our DF, oh, sorry, let me write this. Wow. So we have our DF, and then this DF, we have, if you go back, we are taking row 3 um, to row 5, and then comma, and then row 2 to row 7. What I told you guys that is that anytime you see this in R, it means that from the value at this side, from this value, then to the value on the right. So from the value on the left hand side to the value on the right hand side. And then the comma here is used to separate these values here are telling us that this is what row, and then these values here are telling us that this is what this is the column. So these are to show the rows. So this is row, and then this is what column. But anytime you bring this semicolon, it means that you want to tell us that you want to move from the value on the left hand side to the value on the right hand side. So it's going to pick all the values in between them. So that is what we can do to be able to slice, to be able to take sorry, a slice from our data set. So now we also want to be able to take, I think, yeah, we check this. So we want to check the unique values from our gender column. So here, if we do unique, if we do unique and then we select this gender column, this is going to give us um, male M, F, these, and then these. If we also do this by using the dollar sign to select the column, this is going to give us the same thing. The reason why we need to do this is because we want to know the values in our column. So the unique, what are the unique values in our column? Guess how there is M here, there's female here, and then here this female is spelled F male. Then we have male, we have some unknown values. So this is giving us some idea about what specific things we have in our data set. So we check the education column to the same thing. We have masters, bachelors, and then we have some dashes here, unknown, PhD, high school. We check our region too, and then this gives us northeast. Then we have some dash. If you look at the spellings of the northeast here, and then we also have northeast here. They are the same thing though, but look at the way they are being spelled. This is southwest, but it's spelled in small letters. And then this is Qatar southwest, and then we have southeast. We have some unknown values. So this is telling us what we should be looking out for. If you come to the lab score to the same thing, we have some values, some NA values, and then some 9. So this is also something that is very interesting for us to look at. Then we also check protein expression. We want to know the values that are in here: low, medium, unknown, high, and then some dashes. The symptoms status to the same thing: mild, severe, none, some dashes, and then some unknown values here. So we are exploring the data. We want to know what exactly is inside our data so that we can work with it, so that we will be able to know what to do with our data set. So that is the reason why we need to check. We need to be checking um, all of these things. So this is everything about data science. Honestly, this is everything about data science. You checking your columns, because in data analysis or in data science, um, what is important is you being able to understand your data, because if you understand the data, you'll be able to know what you can do with it. The next thing is that we want to view some basic information about our data set. So we use this function, which is from deep PyR, or which is also from tidyverse, to be able to get a glimpse of our data. So glimpse of the data means like we want to know what is the so what is a general overview of our data, or maybe we can say this is we using df.info in Python. So there it says that we have 500 rows, we have 8 columns. So then the number of columns are 8. We have age, which is this CHR. I told you guys that this is standing for characters, and then it gives us about 1, 2, 3, 4, 5, 6, 7, 8, 9 values from our data set. And then so we have gender, we have education level, we have region, we have these. So this is giving us some information about our data. So just for us to just take a glimpse of our data. So that is what glimpse is used to do. Then we have the next one, which is summary. The difference between glimpse and summary is that glimpse tell us gives us our the number of rows, the number of columns, and everything. But summary is just like how we have this described in Python in pandas. It is going to give us the value. So this is age. How many values are there? The length of age is 500, so there are 500 values. What is a class? We talked about class and then mode last time. So what is a class of this age column? And it is telling that this is a character. So gender. So here we are knowing that our age is age supposed to be integer, but here the age is what a character value. So there is a challenge with this that we need to be able to work with. We have gender here, we have education level, region, we have our lab results, all of them. And then you can see that we have all of them are having values that are 500, 500, 500, 500. So you need to be able to know that. Then the next thing is for us to find missing values. So how do we get missing values from our data set? So we just want to find the sum of missing values in our data set. So if you use call sum, then is NA. Now, if we do this, I want to show you guys this, that if we just do um, is dot NA on our DF, what you are going to see is that it is just going to give us false, 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 false. So this is just going to give us, it will go to the column where it is he an A value? Is he having a missing value? Okay, so this is false. So this is what it's going to do. But then, so here you can see there is true here, there is true here. So meaning that this is an NA value, this is an NA value. But what we are interested in doing is that we want to find the sum of the NA values that are inside our columns. So we want to find the sum of the NA values that are inside our column. How do we do that? So okay, yeah. So I've just commented this one out. So you look at the age and then you can say this is 0, so there's nothing in it. Gender is also 0, education level is 0, region is 0, lab score is our lab score is what 83. So there are 83 values, NA values that are in our lab score. So this gives us an information about okay, what do we do with the NA values? Do we um impute them? Do we drop them and all of those things? So that is what is very important for us to understand. Then let's look at the unique values in each of the columns. So if we run this, we want to find the length of unique values in each of our columns. So we use sapply. I think I don't know if I said this during the time we're dealing with functions, but you use sapply to if you have a data frame like this and you want to be able to perform a specific function that should apply to all of the column at once, you use sapply. We have lapply and all of those things. I want you guys to just read on them. Yeah. So when we do sapply and then run this is telling us that there are 68 unique values in age. There are 5 unique values in gender. Their education is having 6 unique values. Region is having 7 unique values. This having 88 unique values, and then you can just check them out like that. But then Let's look at the next one, which is distribution of our categorical values. So here too, there is a helper function that I'm using, which is going to print the table. So this table is going to tell us um, the values, the value count. So in if you are coming from pandas, like I said, I'll be making reference to pandas because I know most of you are coming from um, the pandas part. Sorry, are coming from Python. Yeah, sorry. And then you know more a little about pandas. If you are not aware of pandas, no problem. We will still talk about that in our Python classes. So what we want to do here, this is just a helper function. I also brought this just for you guys to be able to understand that to be able to understand how we talk about functions and then we can still use functions in here. We can define our own functions and then make use of it because function helps you to be able to keep your code concise because you don't really have to be repeating yourself. So that is the reason why we need functions. Then we want to find the unique values from our gender column. So if you run this telling you that the female, there are 92 values for female, and then this F male, there are 104 values. Male is having this, M is having this, male is having this, and then unknown, there are 102 values for unknown. So this is something that it's very interesting that we know about it. This is like how you do value count in pandas. So let's do the same thing for education. So this is going to give us a table of, okay, so um this dash, there are 93 values of it. So bachelor's is this, high school is that, master's is that, PhD is this. Then the unknown values are 75. This is giving us so many informations. Regions too is telling us the same thing. So we check protein expression. This is giving us this information. So we have this information. Symptoms status too is telling us that okay, we have mild, we have none, we have severe, unknown, and then we have this which is 10, 110. Mutation, gene mutation too, we have yes and no. So we have about 249 no's and then 251 yeses. So we now know what is inside our data frame. So we now know everything that is inside our data frame now. What we can decide to do is to now start cleaning our data because there are some of the things that are inside our data that we don't need. So for example, we don't need this dash because we need to now replace it with something tangible. So let's check that out. We are here. Okay, so we are going to start with data cleaning. So how do we do data cleaning? Okay, so we are still on. Please let me know if you guys are still with me and you can see my screen, you can hear me, and everything is getting clear with all of you before I move on to data cleaning. So, guys, I need your responses for me to know if everything is going well. Pedro, Mohammed, Akin, um, Akintunde. I hope I've not murdered your name. Mohammed, Pedro, Vivian. Oh, it's Mohammed. Oh, sorry. I thought I saw Mohammed. Okay. Yeah. So far, so good. Yeah. Thank you. That's great. Thank you so much for that. Okay. um. Okay. So let's go. Let's move on. Let's move on from here. So now let's talk about data cleaning. Now, anytime you want to clean your data, the best thing to do is to make a copy of your data so that you don't really overwrite you don't be overwriting your data and then you have to run everything from the top and all of those things. So sometimes it's very important to make a copy of your data set that you are working with and then we just go ahead and then clean that data up and then when you are done you can just assign it back or whatever you want to do with it. So let's go. The first thing, so we are cleaning our data. The first thing we want to do is to we saw that there were some dashes and there's an unknown values there. Now let's replace them with NA. So this is just something that I I am doing because this is I have a knowledge of the data set, but in reality, sometimes what you need to do is to be able to seek um, domain expertise. So you need to seek domain knowledge to be able to know what those dashes stand for, because sometimes the dashes stands can can have their own meaning. Unknown can have its own meaning. Maybe you have a dash there, it could be the presence or the absence of something. So you need to be able to seek for domain knowledge to be able to be able to work with the data, because if you don't seek domain knowledge, you might be cleaning something or you might be replacing some things that you are not supposed to replace. So that is what you need to understand. So here we are replacing all our dashes with unknown, and then all our dashes and then unknown values with NA values, because we just want them to be NA values. So this is just something that I'm doing from um, my own point of view. So let's go with it. So the next thing I want you guys to understand is this. We want to clean the, okay, let me pull this one up first and then show you guys what I want to do from here. Good. We want to convert the age, because the age and then the lab results are supposed to be numeric values. If you guys go back to here, you will see that the age is a character value, and then the lab result is what, a character value, but it's supposed to be numeric value. So how do we change it? So to be able to do that, we use what we call the as numeric, and then so we are using as we have as character, we have as logical, all of them here. So we are using the as numeric to force the values to be integers. Okay, so that is what we are doing here. Now, this is very, very important for us to understand that. Look at the output here. It's giving us some warning message. This is not like it is wrong, because the thing is that NAs were introduced by what, by coercion. Why? Because if when we check the unique values in our unique values in yeah, lab results, you will see that we saw 9 here. That is NINE. Now, if you I was trying to replace the 9 here. If you guys see here, I was trying to replace the 9 with this, but if you do that, it's not going to work. If you replace the 9, this NINE, with this 9 value, what will happen is that it will change all the values to all the values that are not NINE, to convert all of them to NA values. So mostly this is something that I want you guys to take note of, that you don't make sure that you convert all of them to numeric first, and then if there are some NA values, you just change it. Because I was trying to do this first before I do this, but it wasn't working. So you take note of that. Maybe I'll find a way around it, or maybe I can give that to you guys as your assignment to go and find your way around it. Because I also try to first of all convert it to characters and then recode it first. So yeah, and then recode it first. I'll talk about recode soon, so don't worry about that. And then bring it back to numeric, which is also not working because it is still going to change this. All the values that are 9 will be changed to 9 though, but the remaining values that are not 9 will all be converted to NA values. So this is something I want you guys to take note of. So the next thing is for us to be able to change our, to standardize our the typos in our agenda column. because we saw that there were F male and then there was capital male which represents what male. So to be able to clean that, what you do is that you use this keyword called recode. So you use this keyword called recode. So this is just like in R we call them like ingredients. So you use these ingredients called recode. And then we want to reassign. So you are using this to assign back to this. If you just do recode and then data frame, and then this is not going to change, this is not going to cause any effect. It's not going to do any changes to this column. It's just going to print it out, and then it will not give you, it will not affect the changes, no affect the changes in the gender column. So we reassign this to it, and then we use a recode. And we want to recode this data frame, the gender column. So to go to the gender column, if you see F male, you should replace it with female. And if you should see M, you should replace it with what? Male. So that is what we are doing here. And then we also want to standardize our region, because if you guys go back, we were having northeast, which we which will be north dash east. We were also having southeast, which is in small letters, which is B in capital letters. So that is what we also do here. Then I don't want us to really worry much about handling outliers, but I just brought it here. For instance, we if you check the ages, okay, let me even use this as an here. That's how we are having 120, and sometimes or even here we have 138, and sometimes in most of in reality you might not be getting age that is more than 100. So mostly the kind of depending on the kind of research though, ages might mostly be less than 100, and then the lab result to sometimes might be less than 20. So you can use this to be able to clean outliers, but I don't really want us to worry much because we are not really going to we are not really considering some of these things. So but just know that to be able to handle outliers, which is mostly optional here, you can remove the ages using this, and you can also remove the lab scores using this. So what do? You use the filter keyword. You use the filter keyword to be able to come and then select the ages that are greater than or equal to, that are less than or equal to 100, and then the lab results that are less or equal to what? 20. So this is something that you can also do. So the filter is also an ingredient in deep IR or in the tidyverse that we can use to be able to filter out some values, filter a value from a column. So we are filtering this column based on what? This value that we are assigning to it. So that is it. Now we've been able to clean our data. What when you are done cleaning your data, the next that you want to do is to be able to what? To review, preview the data. So here we can now see that male. If we go back to this place, if we go back to our data here, where's our data? Where's our data? You can see that we are having capital M male, we're having some unknown values. So if you come back to this place, you can see that we've been able to clean our data. Yeah, our data here. So we have male, female, and then we if you guys remember, we replace all the unknown values and then the dashes with NA. So that is what is happening here, because if you get back to this point, here we data cleaning, data cleaning, data cleaning, data cleaning. Yeah, here we are saying that all the all these ones, that is all the dashes should be replaced with what? With NA. That is what we are doing here. So if it is NA, it should be replaced with what? With NA. And sorry, I did talk about mutate. So we use mutate to be able to um, do changes to values in a particular column. So we use mutate to be able to do changes in the values in a particular column. So that is what this mutate function is doing. So we want to do everything that is inside our data, this data frame. If it is this or that, it should replace with it what with NA. So that is what this line of code is doing. So that is what it did here. And if you get back to this place, you will see that all the dashes, all the unknown values have been replaced by NA. So this is a preview of our clean data. We can now summarize it, and then if we are summarizing this, you can now see that our age. Oh, okay. Even there is something that I even forgot to show you guys here. So look here now. Our age is now what double. So it is double. I When we're treating data types, I think I told you guys about what double is. So this is actually an integer, but in R it represents whole numbers as what as double. So this is something that I made mention of when we're treating data types. Gender is character, education level is character as it's supposed to be, region is character as supposed to be, lab score is double as it's supposed to be. So that is also telling us that okay, so now we've been able to clean our data, and then we can now summarize our data here. So if you look what we have here, um, oh boy, whoa. Sorry. I went off. Okay. Connecting. Please. God. Yeah, rejoin now. Meeting. Oh, God. Sorry. Let's go. Uh, Whoa, what is happening to my screen? Been disconnected. Oh God. Network. Back to this place. And should join. Um. Whoa. Oh. Okay. Sorry. Please, guys, can you hear me now? Sorry, I got disconnected. Let me know if you guys can hear me, and remind me where we got to, because honestly, I don't even know when I got disconnected. Okay, now clear. Yeah, Pedro, Vivian, and Akin today. Please, can you guys tell me where you lost me at? Because I don't know why I got out from. If you guys can remind me where we got to so that I can just go back to that place, because I only realized somewhere along the line of data cleaning. Oh wow, that's interesting. Oh,
Yes, the data cleaning aspect. That's where we
that's where you guys
lost
lost
to.
me. Oh,
Yes, where we started data cleaning from.
wow, seriously. My apologies, because I was just talking to myself. I didn't know I was off. Can you guys see my screen now? Can you guys see my screen? Sorry.
Yes, it's up. But
Great, great.
but your page is yet to come. Okay, it's come up now.
It has come on now. Okay, thank you. Um, can you see? where I've highlighted. Is that where we got to? Yeah, data cleaning.
Yes, that's where we got to.
Oh, okay, that's great. Oh, seriously. Yeah, sorry about that. About that. So, um, quickly let me quickly run through this. So we talk about. I was saying that whenever you want to clean your data, you need to make a copy of it. I think I don't know if you guys got that part. And then, we like I was saying that we just here to be able to clean these dashes and then the unknown values, sometimes they can mean something in your data set. So you need to be able to know, you need to be able to have some domain knowledge. For instance, this dash could be something, it could represent a value, but we don't know yet. So you need to be able to have domain knowledge about that before you can go ahead and start cleaning. But I'm just using this. So here I'm just running this. No, yeah, just for demonstration purposes. So that is what I'm doing here. Then we also want to now convert the numeric value columns, because we know that the age and then the lab results are supposed to be numeric columns, but they are now character columns. If we should go back to here, you can see that the age, its data type is character, the lab result score, its character, its data type is character, but we sorry, we know that they're supposed to be integers. So to be able to clean that, we now turn them to what, to numeric. So we when you run this is going to tell you that it is now what this warning message, it doesn't mean that this code is not working well, but what you need to understand with this is that um, if we go back to the lab results, okay, where we check the unique values from the lab, unique values from lab results, yeah, is that there is 9 here, okay, even though all of these things are values, but there is what, 9 here. So what it is doing, it is that it is now coercing the 9. It is using it's coercing the 9 into NA. So you can see that it is telling that NA is introduced by what, coercion. So all the values that are 9 are now converted into NA values. So that is what this is doing. Then I also told you guys that I was saying that data, we can, I was doing this for us to be able to clean our data sets, but it wasn't working. Why? Because if you do this and then if you want to convert the 9, this NINE to 9 first before you change it to numeric, what will happen is that you'll be having um you'll be it will convert all the columns to unknown values. It will convert all the columns to NA values, which, sorry, all the values, all the other values that are not 9 to NA values. So I wanted to find a way around it, but I just want us to go with just this for now. Okay, so you guys can, maybe this might be your assignment to maybe find your way around it. Okay, so that is, yeah, what is happening here. Okay, so I also said that I also did this. I've shared a notebook with you guys, so you can just check this one out. If you do this, you are going to be getting NA values out throughout the columns. So the throughout the lab result columns. So take note of that. So that is the reason why I've commented these ones out. So then the next one is what is, we wanted to standardize our agenda column, because if you go back to the unique values in our agenda, you see that we're having F male, we're having M, which represents male. And then I was saying that the recode here is mostly, we call them like ingredients in R. So these ingredients is what we use to be able to clean strings. So you have a string here, they want to manipulate this string and then change it to a particular string. So we use this recode. So we want to recode this value into this. So you assign this back to your column. I was saying that if you just run this, this is just going to do it once, but it's not going to affect the changes inside this. So for us to be able to affect the changes inside this, we now assign this to our column here. So that is what to do. We also do the same thing for our region where we change northeast to this, then the southeast, which is the small letters, to this southeast, which is sorry, southwest, which is this, to this southwest. And then I was also saying that we can also handle outliers, but this is optional. Why? Because if you check the ages here, just that we have age that is 128, we have age that is 138. These might be outliers, so you can remove them. But here we are not really interested in data. We are not really interested in creating models or all of those things. We just want to be able to clean our data. So if you think maybe outliers are important for you to be able to remove them, you can go ahead and then clean your data by using the filter keyword. And then want to filter by age. Age should be more than 100, and then the last score should be more than, sorry, it should be less than 100, and the lab score should also be less than 20. So this is something that you can do. Yeah. So after cleaning our data, the next thing is that we now preview our clean data. And then, oh, okay, sorry, I didn't run this. So let me run this and then run this so that we can now come back to run this one. So you can see that if we go back to our data set from the very beginning, if we get back to here, is that we are having some unknown values. Yeah, here, some unknown values, and then some M for male. We also have some unknown values here, and some dashes here, which we said here when we got here, we are saying that, okay, let's change all the unknown values. So here we are saying that the dashes and then the unknown values should be changed to NA. So that is what we did here. And then if you come back to this place, because that is what is happening here. So all the unknown values are changed, all the dashes are changed to NA, all the unknown values are changed to NA in all the columns. So that is what we did here. Okay, let me check if yeah, so I'm still on. Yeah, thank you guys very much for staying. Then we move on to, now we can summarize our data. So we use summary. And what I want you guys to understand here is that look at the age column. Because that previously it was character, but now it has turned to double. When we were treating data types, I told you guys that integers, that is numeric values in Python, in sorry, in R, are mostly treated as double. So even though this is an integer, we can see that this is what a double, this is showing double. And then we also have our lab result, which is also showing that this is also double. So that is something that I wanted you guys to take note of. Cause so now it means that our data set is clean, and then we can move ahead to find. So summary is going to tell us that, okay, we have the age column, so the minimum value. You will see that when we did the summary here, where did we do our summary? Here. So when we did the summary of our data sets, where did we do the summary? Oh God. Um, but we did slice here. Okay, we did summary. No, we read the data set here. We check column names, dimensions. Where did we do the summary of our data set at? Oh God. Okay, yeah, so here, good, great. So when we did a summary here, that age was we didn't see anything like the minimum, the maximum, and the rest. So we're only having length. Why? Because the age was a character. But now that we've been able to clean our data, if you get back to the summary here, you see that this is giving us the minimum value, which is 8. the first quartile, which is this, the median value, the mean value, the third quartile, the maximum value, and then it is given as the number of NA values. So this is the total number of NA values that is in this column. Gender is still character, education level is still character, this is still character, so it's given as a length, but then the lab result is also given as this information. Here too, it's telling us the number of NA values. So this is something. Now let's explore our data using data analysis. So by creating some plots for us to be able to understand our data. So let's take age. Now let's explore our age. For you to be able to create a chart or um yeah, a plot in data visualization. Now we are in data visualization. For you to be able to create a plot, we use ggplot. So ggplot comes with the tidyverse, so you can just call ggplot straightforward. We have ggplot2, which also works well. You can also use ggplot2 and it's going to work well for you. So when it comes to, let me explain how we deal with ggplots here. I Okay, you guys can see my screen still. Please, can you guys see my screen still? Sorry.
Yes, I can see from my end.
Okay, perfect. I hope you can see my board, my whiteboard. So most of you can see
Yes.
this. Okay, so in ggplot, the first thing that you do is that anytime you want to plot you want to create a plot in using ggplot. The first thing is the data set that you are using, and then the next thing is what we call what the aesthetics. Aesthetics. I hope I spelled this thing right. Okay, aesthetics. Now, what is the aesthetics is all about? The aesthetic has to do with um the 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 data that the thing that we want to plot. So if we get back to this place, okay. So this is the data that we want to plot, okay. But then the aesthetic is not telling us that okay. So the what what do we what from this data do we want to plot? Okay, so that is what the aesthetic is about. So the AES is aesthetic. So we want to put we want to put this age in our data. That is in on our chart, sorry, in our chart. Okay, so let's go. So that is the first part. Then you bring this plus. Then when you bring this plus, the second line is telling us that of the type of chart we want to plot. If you want to plot a histogram, we use geom plot. If you want to plot a bar chart, we use geom call. If you want to plot a line graph, you use um, geom. Is it line? Yeah, I think yeah, it's geom line. If you want to, so a series, yes, a time series data, you use geom line. So this second part, so you need the first part. So the first part is your data, and then the column you want to to plot on that data. The second part is now going to be what the geom. So this geometry. So that we want to plot a histogram geometry. So geom histogram is telling us the type of what plot we want to plot, the type of plot we want to show or we want to work with. Now these are just some things that you can put inside your column, sorry, inside your geom hist, just for aesthetic sake, or just to be able to visualize the thing very well for us. These are optional, so let me show you guys this. If I take this out, if I take this out, and then I run this, let's see what we're going to have. So you can see that we have this normal black um, histogram. This is not having any beans. Um, Histogram is mostly used to create categorical, sorry, is used to create continuous variables. So you have a continuous variable like the age. So it's a continuous variable. So you want to be able to get the frequency and then what then the frequency of the values. So that is what we mostly use histogram to do. So that is what we use histogram to do. So you have a continuous variable like age. So you have this and then you have this, and then so here you have the frequency here, the frequency of the values here, and then you have the age that is going to be here. And then um, back in high school, you'd be able to understand that okay, so you have something like this and then something like this. So the beans is telling us the values. So let's say this is one, this is two, this is three, this is four, this is five, and then this is six. So the height of the histogram is telling us what the frequency. So that is that is what frequency histograms are used to illustrate. So here, if you guys look here, this is just something that I created without the this band width. So this bandwidth is used to define then the width of our of these bands that you guys are seeing here. And then the fill, this we just want to have the histogram. This here you can see the value, the colors here is black, so we want to fill it with sky white. And then okay, so yeah, we are still on. Then the color here, it's the color black is just, don't really worry much about this color black. Is just for aesthetic sake. So that is something that you need to not worry much about. You can decide not to specify the color, it's not really going to do anything. Now I'm using this here. I didn't really need to use this here though, but let me just comment this one out and then run this code and show you guys what I want, why I brought this. This is called a theme. A theme is used to just make your plot look nicer. Okay, so you're just making your plot to look nicer. But if you guys, that is what themes are used for. So you can see that we we filled our bars with sky blue, so you can see the colors here, which is the sky blue color. So that is what we use the fill to do. Now I want you guys to observe the background of our chart. If I comment the theme minimal out, so if I uncomment this one out and then run this, you'll be able to see that we have a very nice background here. So it is taking that gray background out. That is what this theme minimal is. There are so many types of themes that you can check it out. Just check out ggplot themes, and then you see them there. You can just use them out. Okay, sorry, I have encountered. You have another class. To go watch the rest of the recording. Oh yeah, yeah. I would send this recording. It would need to be uploaded on YouTube. We'll give you guys a link. Yeah. So thank you very much for joining, Vivian. So let's move on. So that is what the theme minima is used. Then labs, this is labels, okay? This is just labels, but short labs. So we use it to give the labels to our plot. So we have the title. So the title of our plot, you can start here. The title here is age distribution. On the x-axis, we want to have age, and then on the y-axis is what is count. So that is what we use these labs to do. This warning message is telling us that we in this column there are six NA values, so we just remove those NA values out. So remove 26 rows containing non-finite values, that is NA values. So don't worry much about this warning. It's just ignoring the null values that are inside our age column. So this is how we plot age. Now let's check for outliers. So for us to be able to check for outliers, we use a box plot to be able to check for outliers. So here, let me explain the box plots here for you guys to understand what we use box plots for. So let me clean this. Box plot is mostly used to identify outliers. That is, if you have some outliers in your data set, you would want to identify those outliers. So using box plot. Even though, if you guys remember, we um, were able to identify the outliers in our data set. So these how box plots are. Um, so here, so okay, let's go. Now this here stands for the maximum value. This here stands for what we call the third quartile. So third quartile. So I'm using okay, let me just use Q3 so that we go third quartile, or you will see Q3. Then the line in the middle is mostly the median. It's mostly the median. Then this line below is the first quartile, so Q1, Q1, and then this line here, this line here is our minimum value. So now, any value that is below the minimum and any value that is above the maximum are outliers. So these are outliers. Outliers means that they fall outside our the range of values. So this is what box plot is all about. So understanding box plots here, if we come back to this um, place. Okay, yeah, we are still on. If you come back to this, yes, yeah, here, sorry. If you come back to this place, you'll be able to see that there are some values that are above. So these are minimum, our maximum value. These are our third quarter. These are median. These are um, lower quartile. That is Q1. These are minimum value, but then there are some values that are way, 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 way above 100. So if you look here, this 100. So there are values that are way above 100, even to the extent of getting to 150. So these values that you are seeing here, these values that you are seeing here are outliers that we need to take them out. So this is just something that it's giving us some idea. So we do the same thing for our lab results too, and then you see that this also containing so many outliers. Here we are still exploring our data. So data exploration, we want to know what the data is all about. What we need to do. Do we need to drop outliers? Do we need to whatever we need to do? So that is what this plot is doing. I've explained all of these parts already, and then we move on to the next one. So the next thing is the categorical part. Let's um, count, let's plot our values. So if you guys remember when we were doing table, you saw that we're having gender, we're having male, the male, female, and then we're able to count the number of values there. But let's now plot it so that we, because a picture says a lot than words, right? So here too, we use the geom bar to be able to do that. We also have geom call, which we can use, but I want us to use the jump bar for now. Um, we can explore jump call later, but don't worry much about this for now. So we have there's the ggplot, still the same thing. So you have your data, then the column you want to plot, and then we want to fill these colors with purple. Yes, choose purple for you know yeah, you can use blue here. If we use blue here, then we run this is going to change this to blue. So that is yeah, so from here we can now see the distribution. So female, okay, so there are more males than female, and then there are some NA values too. So you can see the NA values is showing we know that okay, there are some NA values, and then how much they are, almost getting to almost above 100. Then education level 2, we can do the same thing. So these ones are categorical values. So you want to be able to analyze categorical values. Here, in fact, NA values is even higher than all the bachelor's, high, master's, and then PhD. There are more NA values in this. So that is giving us some idea. We also do for region, and then this one is having more NA values. We can also do that for protein expression. That one is having more NA values. Gene mutation here. If you run gene mutation here, we have no and yes. We have more yeses than no. Good. So now we've been able to explore our data. Okay, symptoms, the same thing. So here too, there's more NA values than we have for others. Now, knowing that we have NA values can give us, you can say that all the plots that we did, most of them have NA values to be highest. So this gives us an information as to what we can do. We have to drop all the NA values, because if you drop all the NA values, it's going to affect our data set. Or do we input the NA values? But if we want to input the NA values, what should we use to be able to input the NA values? That is this one is mostly going to be something that you decide with maybe the stakeholders, or maybe if you are doing research, okay, you do this, you have to make this decision with the researchers to be able to understand all of these things. So that is mostly what you need to know when it comes to things like this. Now, the next one is what we call explanatory data analysis. That is EDA 2.0. So, this is where we are comparing. This is where we are doing some multivariate analysis and all of those things. So here we want to be able to do analysis of age versus the lab results. Okay, so people that how does age affect lab results, and then how can we compare that with what gene mutation. So um, those how does age compare is age versus lab results as compared by what gene mutations. So um, this is multivariate analysis. So to be able to do that, we have our ggplots, and then we still you have your data set, and then in the inside the aesthetics you um, state the x-axis, which is the age. Then you state the y-axis, because now we want to be able to plot points. So these mostly points are mostly used. So geom points here, the geometry that is geom points here is used to plot like scatter plots. So to compare values, so that is mostly what we use the geom point to do. So we also want to color it by gene mutation here, and then the alpha here is just used to control the transparency of the points that are inside the um the chart. We also use our minima here. Then we also have our labels here that we can do. So if you look here, I don't know if you guys can see this, but we have our lab results on this axis, and then our age on this axis, and then it is colored by mutation. So you check, okay, it means that if you check here, those that are at old age are having more gene mutations here. If you check here, and those that have more lab results score here, if you look here, you can see that we have a high value. This is I don't really want us to dive deep into like explaining all of these things, but I just want you guys to get the idea of what we can do. So this is explanatory. So you use these to make some explanations as to why this is happening or that is happening. Now, you can also check lab score by protein expression. So lab score by protein expression using John box plot. So we wanted to just plot a box plot for this, and then compare it with, okay, so here, if you look here, you'd be able to do some analysis. Okay, so gene expression level, those NA values as usual are taking high score here, but then those that are having low protein expression are having high score here. If you check here, so this is something that you now use this to explain to your stakeholders what you've seen. The next one is average lab score by education level. Do people who have high lab scores, what is the education level? Like those who are educated, do you have more lab scores? You confirm that using the jump core. So this is what you use jump core to do. if you get back to jump bar here, you guys can see this is jump bar, and then this is jump call. They you can use them for the same thing, you can use them for the same purpose though. But then here we are first of all summarizing this by average score, meaning that we want to take the mean of lab score, because if you look here, we wanted to find the average lab score and then plot that. So that is what we are doing here. So here we are using the jump call to be able to do that. Let's try using jump call here and see if we get the same thing that we have here, just to illustrate to you guys. So we change this to jump call here, and then if we run this, good. So this is what I want you guys to understand. The reason why this is not working is because um, jump call is mostly used for oh boy, for summarization. Oh God. Okay. Okay. So please take note of when to use jump call. Where is it? Where is it? Where is it? So here, while error, while reach display. Okay. Yeah. So error in jump call. So the problem is that, yeah. So here, problem while setting up jump. So the error occur in the first layer. Why? Because jump call requires the following missing aesthetics. Okay, so it needs to have um we need to have a function that is we need to define something before we can use jump call. So if you get back to this place, um this place where we took this uh from, let me just run this so that we don't get to that last screen. Oh, where are we? Okay, yeah, sorry. So here. So you can see that here we are using jump call because we did a summarization here, and then we now came to do this. So we are just summarizing everything, and then we are taking medication level. We are just reordering these. Yeah, so just to be able to like get this thing out. That is what I want you guys to understand, that you use the jump call. The jump call is mostly used after you bring you are summarizing your data, or you are using a specific function to be able to get something out, then you use the jump call to be able to do that. There are some caveats, but I don't really want us to dive deep into this because we are not really into, probably when we get to data analysis and data visualizations, I'll maybe dive deeper into that, depending on the time that we have. Now, we can also check gene mutation versus the symptom severity. So, using the jump bar too. So, you can see here, I hope I am still on. Oh boy, good, 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 good. Okay, so back to this place. So here we just wanted to, like I was saying, I don't want us to really dive deeper into what jump by is, what jump call is, when to use what, because I would rather talk about this when we get to data analysis and data manipulation. So take note of that. So here we have this. We've colored it. We we are filling this by gene mutation, meaning that we have mild, and then we give it a color. Yeah, so that is mostly we are using the gene mutation to be able to give the color to the bars. So that is mostly what we do here. Then we come to correlation. Oh, show difference savings fail. Okay, so save this. I hope I'm still on. Yeah, so I'm still on. So let's move on from here. So this is where we use the yeah, here. So we want to find correlation, okay, in our mostly for numeric features. So to be able to do that, we just have set our um the numeric columns. So we want to select only the age and then the lab results. And then we also want to be able to drop any NA values from that. So if you run this, this is subsetting our um, column. This is subsetting our data set, that is our clean data set, to be able to take only, so it is selecting only the age and the lab result column. And then we also want to be able to drop all the NA values. Then we use this is the what we use the ggali for. So this function only comes from ggali. You can't use this function is not in tidyverse. So we call this function from ggali, which is the gg call, and then we pass um our data set to it, and then we want to give it the label. So the labels are going to be the columns that we have, and then the label run, um, we just want to round the values to this. Palette is just for the color, so you set the colors that we want, and then the name we want to give it is what is our correlation. So like I said, don't really worry much about um, this these visualizations, but when we get to data visualizations, maybe we'll talk more about that there. So this is telling us that okay, the age and then the result, this is the um, correlation value among them. Maybe you have more, if you have plenty or many numeric values, you just select them out and then you filter them like this, and then you do this, and then you are able to get something that is going to look like this. So this is everything that I have for you guys today, and this is the project that I said we'll be doing today, and I hope you guys have found some value from it, and then you've also learned something. Like I said, I created these data sets. It's a synthetic data that I just generated myself. If you need the Python file for it, you can hit me up in the on WhatsApp, or yeah, on WhatsApp mostly, or you can just yeah, comment. You can just um send your comments, and then it can be sent to you. So if you have a question for me, you can ask now. If there is no question, then I think we are done for today. Any questions, any confusions, anything that we need to talk about, or anything that we need to iron out? Okay, thank you, Pedro. Thank you so much for um, having for getting something out of this. I'm very much grateful that you found this insightful. Yeah. So, any other questions, any other confusions, any other thing that we need to talk about before we run this out? No questions, nothing. By the way, I would like you guys to, where is this? Where is this? To fill a form. Um, Copy link address here, because we want to be able to let to understand whether what we've been helping you guys with is very insightful. So please try and fill this form for us. We want to, your feedbacks are very important to us, so please try and fill the form, and then let us know how these classes have helped you and everything. So that is it for now. If you guys have any questions for me, you can ask. If there is no questions and there is nothing else to talk about, you can request the notebook, and then the notebook for generating the data in the in our chat group. And if there is no question, then I'll see you guys another time. Thank you all so much for coming, and we'll catch up next week. Bye bye.